The section is going to be over complex fractions. Now what you're going to see is up here in the top of the title it's going to say division of polynomials, I believe, but anyway, it was a mistake. That's actually the next section. So remember, we're going to be simplifying complex fractions in this series of in this particular video here, which is somewhere around 40 minutes long or something of that nature. But it's complex fractions. You're going to see division of polynomials. That's not correct. Just remember that it is complex fractions, because I'm not about to go back through and redo all those problems. So complex fractions, remember that. Alright, thanks. Alright, in this section here we're going to be discussing division of polynomials. Of course, not much of a discussion other than I'm going to be working out examples, because that's what everybody wants to see. How do you work this problem? Let's start with a couple rational numbers here. How about we're going to do this little refresher here real quick. We have 1/7 divided by 2/9. And I want to simplify this thing down. Alright, so that's what we're doing here. Remember, I can write 9/2 times 9/2. Okay, well, we do the top, we got to do the bottom, so forth. Alright, this right here, those cancel out, so you're left with a 1 in the denominator, and so we have 1/7 times 9/2. And of course this can actually be rewritten as 1/7 times 9/2, and there's nothing that goes in 9 and 7, and we can't simplify that down anymore, so this becomes 9/14. So the whole idea is we want to get this right, turn this basically into a division problem and into a multiplication problem. From a division to multiplication is what's going on here. Okay, so let's actually work something that's got some variables involved. So let's say that we had 3x and it was over 2y squared, and that's all over 5x to the 4th over 4y cubed. So we do the same thing just like in the example, and I'm not going to do this every time, okay, just to let you know. We're going to take a shortcut on this. Alright, so we're going to do that. This will be the last time we do it this way, then we're going with the shortcut. Alright, so remember, this all becomes 1 because these guys cancel out, and so we're end up left with, you know what, I'm gonna write that down here. We're going to be left with 3x over 2y squared times 4y cubed over 5x to the 4th. Alright, I'm going to take this 3 times 4, and this is something else we're not going to do every time, but I'll do it this time. This is x times y cubed, and that is grouping our integers together there. And we have y squared times x to the 4th, right? Or y squared and x to the 4th. Okay. Well, 2 goes into 4 2 times, and 2 times 3 is 6. So we're going to be left with a 6 here. Alright. X, we have 1x and we have 4 x's in the denominator, so we can cancel this x out and we'll just be left with 3 x's in the denominator. So let's see, and I'm going to write that 5 right there. So 3 x's. We have 3 y's in the numerator, 2 y's in the denominator, so we can cancel the 2 y's out in the denominator, and we're left with 1 y in the numerator. Alright. So we have 6y over 5x cubed. Okay. that was simplified down. Let's see here. We have we're going to learn about that. Add the layer 2ab over 5xy, and that's all over 11x cubed y, too many horizontal lines, 4a squared b. So in this particular one here, we're going to be doing the shortcut. Alright, I'm not going to be multiplying down here by its reciprocal. So we're going to say 2ab. So I'm going to write 2ab over 5xy times. Now we're going to take this and flip this. So this becomes 4a squared b over 11x cubed y. Okay. Is there anything I can cancel out? That's what we have to look at. Is there an a down here anywhere? No. A b? No. No b's. A squared b? No. So it doesn't look like there's anything here we can anything we can cancel out. So we got, let's see, 2 times 4 is 8. A times a squared is a cubed. And b times b is going to be b squared. And that's all over. Let's see, so 5 times 11 is 55. We have x times x cubed is x to the 4th. And y times y is y squared. Okay, so no, there wasn't anything that we can... so these are both equal. Wow, what an equal sign, okay? Alright, moving on. We are going to move on to bigger and better things, hopefully. Alright. Okay. We have 5x, and we have that, which I'm never going to learn to do something before so that doesn't come up anymore. 5x plus 3 over 2x minus 1, and that's all over x plus 4 over x minus 2. Alright, so I'm going to take this and flip it, and we're going to rewrite this as 5x plus 3 over 2x minus 1 times, right, this becomes x minus 2 over x plus 4. Alright, and it doesn't look like there's anything we can cancel out here. So I'm just going to leave it in its factored form. You can multiply it out if you like, if you're bored, I guess. X minus 2 over 2x minus 1. But of course this would be how we'd want to write this. And of course you can multiply all this stuff out, right, if you want. Okay? I'm just trying to get you to this point right here. So this up here is equal to what we've got here. Alright. Click. Next. Alright, let's see. We are going to do... better add a layer. Alright. X plus 7 over 4x squared. And that's all over x minus 1 over 8x. So I'm going to rewrite, this is x plus 7 over 4x squared times 8x over x minus 1. I guess I could write this here like this is equal to that. Alright. Now in this particular one we can cancel some things out because we have a 4 in the denominator and 4 up here in the numerator, so 4 goes into 8 two times. Now I'm going to write this like such, okay? 2 times x plus 7, because we have an x plus 7 here. 8, there's 1x, there's 2 x's down in the denominator, and so we're going to be able to cancel this x out. So that's all we're left with in the numerator. And let's see, so we canceled out one of the x's, we're left with an x, and of course, and this is going to be x minus 1. And if you like, you can distribute this 2 across and the x cross, but I'm going to leave it right there. All right. So we progressively get into more complicated problems. We have 4 minus 7 over x, and that's going to all be over 3 minus 2 over x. Alright, first thing I'm going to do is I'm going to work on the numerator first, and then we'll work on the denominator. So I want to get this all into one single fraction here. We're going to have going to need to get a common denominator first off. So I write x over x next to 4 so we can get a common denominator. So now we have 4x minus 7 over x. So that's going to be the numerator. Now let's work on the denominator. We're going to have x over x times 3 minus 2 over x. So now we have 3x minus 2 over x, and so that's going to be the denominator, and that's going to replace the numerator there. So let's just write that right over here. So we have 4x minus 7 over x, and then that's going to be all over 3x minus 2 over x. Okay, so we rewrite, this is 4x minus 7 over x times, and remember we're going to flip this guy here, so this becomes x over 3x minus 2. So now as you can see, we can cancel out these two x's. And I end up writing this as 4x minus 7 over 3x minus 2, and that's as far as we're going to be able to get. Alright, simplified down. Alright. We are moving along. Okay. We're going to have 3 over x minus 1 over y, and that's going to be all over 6, which is going to be over 5x cubed y. Alright, so I want to simplify this down. I'm going to work on the numerator first. So we need to get a common denominator, and that's going to end up being, I'm going to write y over y times 3 over x, so that's see y over y goes here, minus 1 over y, and of course we're going to write x over x. Alright, so we'd end up having 3y over yx minus x over yx. As you can see, we have common denominator, so we just add the numerators, so we end up with 3y minus x over y over x. So we've taken care of the numerator, and really there's nothing we can do with the denominator, so I'm just going to rewrite this 3y minus x over yx, and of course this is all over, remember, 6 over 5x cubed y. Alright, so this is the new one now we're going to work with. So what we're going to do now is just rewrite the numerator, 3y minus x over yx, and of course we're going to bring this up, but remember we got to flip this, so this becomes 5x cubed y over 6. All right. So now we got to ask the question, what's going to be canceling out? Well, we have a y in the denominator, we have a y up here in the numerator, an x, and 3 x's. So we're gonna, let's see. Okay, so x, so we're gonna be left with 2 x's and a 5 up here. So I'm gonna rewrite this as 5, start a parentheses, 3y minus x. Y cancels out, and I ended up not writing, let's see, there's going to be 2 x's and I didn't write that right there. We'll write it right here, over, and what's going to be left in the bottom, we have a 6, y canceled out, and an x canceled out, and that's it. So, and we'd normally, if we're going to write a 6 in the bottom, we'd like write it right here in the middle. Okay, write it in the middle. Okay, man, we are moving along. Before you know it, we'll be into college algebra, and then you'll be learning trigonometry, and then we'll move to calculus, and then you'll learn differential equations, linear algebra, discrete mathematics, maybe advanced cal, abstract algebra, and you know what? You'll be a math major. Okay, amazing. Then you can go get you a job at Lockheed Martin or somewhere, or maybe Raytheon or something like that. 1 over x to the 4th minus 1 over y to the 4th, and that's going to be all over 1 over x squared. And if I get a chance, I'll be doing some chemistry and physics, pretty much everything I learned in college. 1 over y squared. And if I even get more time, we'll learn Java and JavaScript and some programming languages. Yay! Okay, let's look at the numerator up here. Let's take care of that first. Okay? And I don't know, I'll write it over here. What the heck? We got to get a common denominator. So I'm going to write y to the 4th over y to the 4th times 1 over x to the 4th minus 1 over y to the 4th, and we're going to be writing x to the 4th over x to the 4th here. Okay, so rewriting all this, y to the 4th times 1 is just going to be y to the 4th, and of course that's over y to the 4th times x to the 4th minus x to the 4th over y to the fourth, x to the fourth. Okay, so we want to get this one single fraction here. We got y to the fourth minus x to the fourth over y to the fourth and x to the fourth. Okay, that takes care of the numerator. Now let me just put a square around all that, box it in. Then we'll work on the denominator. So this is going to end up being y squared over y squared times 1 over x squared plus 1 over y squared times alright, and then we're going to write, let's see, x squared over x squared. Okay, I know that looks like a mess, but we're going to get it worked out here. So this is y squared times 1, and you know what, I think I'll just write it over here. So this will become y squared plus x squared over that common denominator, y squared x squared. Right? So this was in the numerator, this was in the denominator here. And actually, you know what? We just put a line right here. How's that? Save me some trouble writing. So it's this over this. And so now what we're going to do is just, I guess I'll rewrite it somewhere here, if I can squeeze it in. Y to the fourth minus x to the fourth over y to the fourth x to the fourth times, now remember we're going to flip this, so this becomes y squared x squared over y squared plus x squared. Alright, now we want to simplify, see if we can cancel some things out. We have 2x's, 2y's, so we'll be able to cancel that out there. So okay, so I'm going to rewrite this. I'm going to say equals. This is equal, right, to the top up here. So we say y to the fourth minus x to the fourth, and I guess I'll start a parenthesis. Actually, I don't need a parentheses, but since I started one, I guess I'll just finish it there. We're going to end up with a y squared and an x squared in the denominator. Because we have two y's, we're going to cancel two of them out down here, so it's going to be left with 2, and same thing with x. And of course then we have y squared plus x squared. But we're going to be able to factor this piece right here, and I'm going to do that right over here. This can be rewritten as y squared, and it's all squared, so 2 times 2, as you can see, is 4, minus x squared, and all that is squared. 2 times 2 is 4. But what we have here is we've got the difference of two squares. So as you can see, we can rewrite this as y squared minus x squared times y squared plus x squared. So we can take this denominator up, or numerator, and rewrite it, and that's what we're going to rewrite it as. And as you can see here, we're going to end up being able to cancel out some stuff. Y squared plus x squared over y squared x squared times y squared plus x squared, and of course you see we can cancel those out, and we're going to end up being left with y squared minus x squared over y squared x squared is our final. And of course, see this? This is the difference of two squares. But that's not going to help us out. So this is it. All of that nutty stuff up here all reduced down. So we got to remember what the original, what we started with. So this is what we started with, and it all reduced down to that. Okay. All right. Okay, let's see. I think on this problem here you should write it down and pause the video and try to work it out. So let's say this is a quiz for you. Right, so pause the video and try to work this one out. And then come back and see how I actually worked it out. Okay? Alright, we're going to start with the numerator. And we want to get that into one single fraction. And so I'm going to, I don't know, write an equal sign right here. How's that? We're going to write y over y times 1 over x, because we got to get that common denominator. 1 over y and x over x, and of course remember this is all over 5. Okay, I'm going to try to be a little bit more neater. So y times 1 is just y over yx minus x over yx. And you know what, I'll do it like this. Have you ever seen it like that? Right, same thing. This bar, same thing. Alright. So we're going to join these into one single fraction, so you get y minus x over yx. And of course that's all over 5. I'll write it like that now. So we have y minus x over yx times, now we're flipping this. This would normally be a 5 here if this were divided by, but then we write 1 over 5. Okay. And it looks like this is all going to reduce down to 5x y. So there you go. Hopefully that's what you got. Hopefully. Alright. We're going to have 4 over 1 over x plus 3 plus 5 over x minus 2. So we're going to work in the denominator this time because there's nothing we can do up here. So we want to get this into one single fraction. And I'm going to write an x minus 2 over x minus 2 times 1 over x plus 3 plus 5 over x minus 2, and then this time we'll write x plus 3 over x plus 3. Okay, so we're going to have x minus 2 plus 5 times x plus 3, and instead of writing two separate fractions here, I'll just skip that step. And we got x minus 2 times x plus 3. Alright. So we have 4 over. Now I'm going to go ahead and what do we got? Distribute this 5 across, plus 5x plus 15 over x minus 2 times x plus 3. Right, trying not to skip any steps. We're going to go off in this direction here. I'm going to end up running out of room. So we're going to have 6x plus, what, 13 it looks like. And that's all over. Let's see, 6x plus 13, okay. And then I'll just rewrite what we got down here. We have x minus 2 times x plus 3. Alright. So now we're going to take this denominator here and we're going to flip it. We're going to flip it, man. Okay, so that gives us an x minus 2 times an x plus 3, and that's all over 6x plus 13. So we really want to take this 4 and write it up here with them. Now, I'm just going to keep this stuff in factored form up here in the numerator. You can multiply this together if you want. Alright, so there we are. That's a done deal. Okay, moving on to bigger and better things, maybe, hopefully. And let's center. Do some centering there. I guess that's good enough. Alright, what do we got next going on? This looks like this will probably be my last problem in this section. Hopefully you have gotten the hang of it. And on my website, which is, there's a link on my YouTube channel, I should have exercises where you can work them out. Okay, we can rewrite this x to the negative 1 as 1 over x minus, and you can rewrite this as 1 over x plus 5, and that's all over 6. So we want to get this as one single fraction here, so we're going to write x plus 5 over x plus 5 times 1 over x minus 1 over x plus 5 times x over x, and of course that is all over 6, remember. Sorry about my address there. It's in the way, kind of. I have to put that there because I have people who like to steal my videos, put them on their website, and make money with them. Yep, there are people out there that do those kind of things. You know, it's like, why don't you learn some math and do your own videos? Why do you gotta steal my stuff? It's really annoying. Anyway, sorry about that. I gotta rant and rave about all that kind of stuff. Okay, so we have 5 over, and when you go to people's videos, and you see this, they're doing that for the same reason. Same reason. Alright, let's get back to this problem. So 5 times 1 is 5. We always want to write our integers, write them out in front. Well, this problem actually wasn't that difficult, we ended with. But there it is. Now you can go ahead and distribute the 6 across inside if you want, but I'm going to just leave it like that. Alright, well, good luck, and I think the next section is what is the next section? Did I actually name this wrong? I'm going to be so mad. Division of polynomials. Wow. I just realized that this section is not division of polynomials, but it's complex fractions. Complex fractions. I'm not going to redo all these videos because of this. Oh my